Okay, 13.1, greatest common factor and factoring by grouping. Okay, we're going to find the greatest common factor of a set of terms, factor polynomials by factoring out the greatest common monomial factor, and factor polynomials by grouping. Okay, procedure for finding the GCF of a set of terms is find the prime factorization of all integers and integer coefficients, list all the factors that are common to all terms, including variables, raise each common factor to the smallest exponent on that factor in the list, and multiply these powers to find the GCF. Notice there is no common prime factor or variable, then the GCF is 1 and we won't be pulling out anything. What does that mean? Now, a lot of this they're going to be doing the long way. We will eventually get to the point where a lot of this you're just going to be able to see. You can kind of do a guess and check if the numbers get kind of large. Okay, notice here we're finding the GCF for each of the algebraic terms. Okay, we're going to come in here, grab a pen. Okay, we're going to do 30, 45, and 75. And notice here for A is we're going to have the prime factorization of each number. Okay, we got 30 equals 2 times 3 times 5. Okay, and then for 45, well, remember that means 3 times 3 times 5. I'll kind of write that down right there. 3 times 3 times 5. But 3 times 3 is 3 squared. And then 75 is 3 times, okay, well, it's going to be 3 times 5, which is, of course, 5 squared. Okay, well, notice this does not have a 3 squared. This does, this doesn't. Okay, this has just a 5, this has just a 5, this has 5 squared. And so notice we're looking for like the greatest common one. Okay, well, the only common ones are the single 3 and the single 5. And so therefore the greatest common factor is whenever you multiply 3 times 5. Okay, and that creates this 15 here, which means we could pull out a 15, okay, which is what we're going to eventually start doing. So let's go over here to the next example. Okay, well, notice what they did here. They used 20, 15, and 10. Okay, they prime factorize it out. 2 times 2, okay, 2 times 2 times 5. Here, just 3 times 5. Here, 2 times 5. Well, notice that 2 squared doesn't happen anywhere. Well, first off, this one doesn't have a 2, okay? But this one does have a 5. This one has a 5, and this one has a 5. And they're singleton 5s, see? So, notice we have a prime factorization, or not, sorry. We have a common factor of 5, which it says right here. And then we can look at the powers of x. And we always go with the lowest one because we notice that this x to the 5th, well, there's still at least 3 x's in it. This x to the 4th, there's at least 3 x's in it. So that's how come they say x to the 3rd is 1. And then y, these are all raised to the power of 1 except for this one here, which we know there's a power of 1 in there. And so therefore, we know that this right here, okay, would be our GCF for all the terms. So finally, factoring out the GCF. Find the GCF, which is what we just done, of the terms in the polynomial. Divide this monomial factor into each term of the polynomial, resulting in another polynomial factor. The product of the GCF and this new polynomial factor is a factored form of the original polynomial. What do they mean by this? Okay, let's do some examples. First off, let's look at this first one here. Okay, this first one is 6m plus 30. Okay, let's pull out the pen here. Notice the 6, okay, we'll go ahead and do the 6n first, okay, and then we'll do the 30. Now, I'm going to show you how to do the prime factorization. Eventually, you're just going to be able to see these, because you're going to be able to see, okay, 6 and 30, I can see the greatest common factor in that. But let's think of the prime factorization of this one. It's going to be 2 times 3, and also we got that n, okay? Here, if we think about it, we've also got 2 times 3, but we've also got a 5, because 2 times 3 is 6. Multiply that by 5 and we get 30. So there's the prime factorization there. But notice we don't have an n. Okay? So the only prime factorization we have here is going to be the 2 times 3. Okay? So our GCF is going to be 6. Okay? So if we factor that out, what's going to happen here is, let's say we do this, put a parenthesis around this, and we're going to divide everything in here by 6. Now, whatever our GCF is, we want to pull it out. We want to put it right out here, okay? And so notice 6 divided by 6, well, that's just going to cancel out and leave the n, okay? We can leave the plus. Okay, and 30 divided by 6 is going to give us 5. And that is the factored form of this term here, of this expression. Because notice, if I go ahead and distribute this back in, then you got 6n plus 30, and you should always be able to get back to the original form. Well, notice the same thing with this one. Without having to do any sort of prime factorization, we should be able to look that this is a power of 1 here. Okay, so if I pull out just 1x, because we know that there's at least 1x in this one, let's come over here and just pull out that 1x. Okay, well then we can divide everything by this x. Okay, well notice this is x to the power of 1, which is going to give us x squared, plus, well notice these x's, they don't just disappear and go to 0, okay? These have to go to a 1, okay? And once again, if you decide to distribute this back out, then of course you're going to get back to your original equation. Let's continue on. Okay, 5x minus 15x squared. Okay, this is kind of a combination of the last one we just did. So let's kind of look at it here. So we've got 5x. Well, we know that the, prime factorization of this is just 5. And then we've also got an x to the power of 3. Well, let's look at the 15. Okay, x squared, well, that's going to be 3 times 5, and then we're also going to have that x squared there. Well, notice that the 5, okay, here is the only multiple that matches in both of them, so we can put a 5 over here for our GCF. Okay, and then notice that x squared is the smallest variable with the smallest power, so we know there's at least going to be 2 x's inside here. So we can pull out an x squared. Notice how you're going to just finally start hopefully kind of seeing these. If not, just plenty of practice, okay? And you're going to be able to see them. You don't always have to do this prime factorization, but do it while you need to, okay? So we know this is going to be our GCF, so he's going to get pulled out. So let's put him out here, okay? And then we'll put a parenthesis in here. So how's this going to look? Well, we've got 5x to the third, minus 15x squared, and then we can divide all of that by 5x squared, and then do the 5x squared here. Well, notice the 5's cancel, these all cancel, and then I'm just left with 1x there, so I'm going to be left with x right there. Here, the 5's canceled, this is going to go to a 3, and then of course, all the x squares cancel. So this is going to be minus, okay, 3. Now, if we look at this, if I decide to distribute this back, notice 5x squared times x is going to be 5x to the third, which is what we originally had. And then 5x squared multiplied by that negative 3 is going to be negative 15x squared. And so this works out. And let's continue on. Okay, factor 2x to the fourth minus 3x squared plus 2. Well, I think we can tell that, let's look really carefully here. Notice none of these are going to cancel right there, okay, because there's no sort of common factor other than 1 here. Okay, we'll start looking at the other parts. Okay, we've got 2x to the fourth minus 3x squared plus 2, and if you had to do this as a prime factorization, well, you know that the prime factorization of 2 is just 2, and then you're going to have x to the, put that x to the fourth there. Well, you've got this 3. Well, it's also just going to have 3x squared. I quit forgetting my variables, don't I? And then you've got a 2 with just a 2. Notice nothing matches. I mean, we've got a 2 and 1 in the first one and the last one. So what this one you would say about this one here is it's not factorable. Okay? If you can't find a way to pull anything else and make this more full of GCF out, it's not factorable. It's in its simplest form. Okay? So factor each polynomial. These have already kind of been done for you, but notice you've got some common terms in here, and these are very important. You're going to start seeing things like this. Okay? So notice we do have a common factor here. Okay? These are being multiplied right here. So what we can do is to factor these out, we can pull one of these out. Okay? And then notice we're just left with this right here. When you factor that out, we're just left with the 3x okay, squared minus 2. Okay, and just FYI, it doesn't matter what order you put these in, they're commutative, so you can flip them around, doesn't matter. Okay, well, notice here in the next one we can do the same thing. Notice we've got that 2x minus 3, those both match. Okay, well, notice whenever I pull out, if you're not careful in thinking about this, remember this is just division. So if I came in here and said I'm going to divide everything by this 2x minus 3, and then do it over here, 2x minus 3. Matter of fact, let me get rid of that long line there because I don't want it to look confusing. And I'll do this as two separate lines. Okay, well, notice what's going to happen here. This cancels out. Well, notice what happens here. This cancels out as well. Well, what's left if these all cancel out? Here's my guy right here. And remember, just like before, we put parentheses around this. Well, I'm left with a 7a plus. Well, that's how come, since this cancels, it reduces down to a 1. Okay? So that's why, if you ever see something like this happen, it's going to reduce down to a 1. So let's do one more. Okay. Factor the polynomials by grouping. Okay. Grouping means you're going to end up having 4 terms. All it means is to do this. If you see something with 4 terms, I can come in here and literally, I'm just going to go ahead and throw parentheses around each one of these. Okay? And then I'm going to start looking for the GCF in either one of these. And notice in this first one, it's going to be an x. So let's go ahead and divide out of x on this first one. And let me pull it out. Okay? And then I'll put a parenthesis right here. Well, in this first one, the x's cancel. Now I'm left with y plus, here they cancel, y plus 5. Well, what do I got over here? Notice that the GCF, this is not a y, but if I start doing the prime factorization of this, I could notice that 3 is going to be my GCF. Okay, so come in here, and I'm going to divide out of 3. And I'll go ahead and pull it out, go ahead and put my parenthesis. Well, when these 3's cancel, I'm left with y, keep the plus, and then 15 divided by 3 is 5. Notice I'm not done yet, though. Okay, I've got this y plus 5 here, so let me go and put that over here. Okay, let me go and throw up another parenthesis here, and notice I've got this x. Okay, we've got an x there. Well, this 3 here, I know you're not seeing whether it's plus or minus, but remember, that's a positive 3. So I can go ahead and just put that down as a positive 3. And if you decided to FOIL this back out, you would get back to your original equation right there, and it would all work out great. So that's how we're going to be doing GCFs, and you're going to be doing GCFs and factoring by grouping a lot. So it is well worth the time and effort to maybe look up some extra steps, get with me or email me or whatever, and I can throw you down more practice work. Knowing your multiples is going to help out a lot. So really for GCF, I'll even put this down here, know your multiplication tables. Okay, very important. Okay.